Hi everyone, welcome back to my channel. If you are new here, welcome. If you are a returning subscriber, welcome back. If you are new, don't forget to subscribe and be part of our family. And before we start with today's topic, please don't forget to like this video, share with others, do subscribe if you are new here, and follow me on Instagram for some extra motivation. You can see my Instagram handle on the screen, and do let me know if there is a topic you want me to cover, if you have any queries, and any feedback is always welcome. Without further ado, let's get started. Hi everyone, welcome back to another video lecture, and today we're going to discuss Dunder methods or magic methods. The reason it's called Dunder method or the reason it's called magic method is because it's like magic. You don't have to call it, user doesn't have to call it. It is called or invoked, it is invoked automatically. When you call a function, it's called invocation or invoking, right? Invoke is like call a function. So these are magic methods. You don't have to call them. They are called automatically when certain actions are performed. Okay, so that's why they are called magic methods or magic methods. And the syntax for these methods is double underscore as a prefix and as a suffix. So we'll have name of the method and then double underscore. We have two prefix underscores and two suffix underscores in the name. And dunder also means it's D plus under, so it's double underscore. Okay, and one of the examples for this method is main, underscore underscore main, right? And then underscore underscore. And when you write the name of the method using prefix and suffix underscores, it will look something like this. Okay, so it's really hard to identify if there are two underscores or just one. It looks like one underscore, right? But there are going to be two underscores. Okay, so when you will actually type the name, it will look something like this, but just remember that there are two underscores. Okay, and I have also I actually created a few videos. They are somewhat related to this concept, and I'm going to link them in the description box below. And so this is a little introduction about these methods. You don't have to invoke them or call them. They are automatically invoked. For example, now I'm going to give you an example. When two numbers are added, when you add two numbers, you make use of plus operator, right? This is the operator that we use when you add two numbers, right? So we make use of plus operator. Now, when two numbers are added using this operator, by default, a dunder method gets invoked. And the dunder method associated with this operator is add. Okay, this is the dunder method associated with this operator, add. This is the dunder method. Okay, and so you can add two numbers using, so I can add two numbers. Let's say I have a equals to 9, b equals to 8. So you can go like a plus b, right? Or you can use dunder method when you use this operator a plus b, by default dunder method gets called and it returns the result. But so that's like a magic method, right? But you can also use this method explicitly. So for that you can just type a dot double underscore add double underscore and b. Okay, so this is how you can use it, right? So I hope you understand what a Dunder method is. It is invoked or called by default, but that doesn't mean you cannot use it. You can use it, and you can actually check all the Dunder methods of a class using dir function. Okay, dir function can be used. For example, we have int class, right? If I check the type of A here, it says class int, right? Class int, right? So if I want to check all the methods in class int or other, attributes of this class, I can use dir and int. So we have all these, see, add. So we have all these Dunder methods here. We also have add method, right? And yeah, obviously int is a data type here, but it's also a class because I told you everything in Python is an object. Okay, so int class, these are all the Dunder methods and many other attributes. We have add Dunder method here as well. All right, so Dunder methods are also used for operator overloading, and we'll discuss that in later videos, and method overriding as well. So for the most part, Dunder methods are used with classes, and like I said, there are a few video lectures that I created in the past. They are somewhat related to this concept, and if you just look at all these videos, you are actually going to understand the concept better, I believe. So I'm going to link those videos in the description. Okay, so I'm going to give you an example here. Yeah, let me start with a very simple example, and this video lecture is actually going to be, yeah, I think it's going to be pretty long. Let's see. So I'm going to create a file here. Okay, so we are going to create a class, and I'm going to name that class family. Now in a class we have two main things. We have data members, right? And these are attribute. We have methods, okay, and data members. Basically class can have many objects, and object will have attributes, it will have methods. Attributes meaning that it will have a name, right, a certain kind of a characteristic that helps us, that can help you understand the object better. And then methods are the actions that the object can perform. So for example, if the object is a car, class could be a vehicle, right? And the object would be object can be car or a bike, right? And if the object is car, attributes can be its color, right, model number, brand, whatever. And then methods would be speed of the car and all that stuff, right? So in this case, I'm going to have attributes, because when I say class family, it means there will be members of the family. So we will have name, so let's say XYZ, and then we have age, let's say 10. Now what happens is, once you have a class, you can create number of objects. So I'm gonna save it first. I'm gonna say example 1. Okay, run it. Now I'm gonna create objects of this class. So how do we do that? I'll take any name. So I'm gonna take object 1 and then family. Family is the name of the class. Okay, and when I use these parentheses, it's like object is being created. So this is first instance of the class. Okay, so first object got created, and what happens is, now how does it actually work? Let me show you how. Whenever you have a class, so let's just say we had class family, right? And okay, and in this class we had name and age. Now every time you create an object of this family, it gets created and it will have those members of the class. So for example, in this case, I created first object 1. So this is how it will be created. So this will be my first object, object 1. The moment I do this, the moment I write this statement, object 1 equals to family, this object gets created and it will have name and age. Okay, now in this case, since we already have values for name and age, this will be initiated with those, whatever values were there, x, y, z, and 10. So x, y, z, and 10. And to access those values, I can just go like object 1 dot name and object 1 dot age. Okay, because there already were these values, but you can also change them specifically in this object, not in the class but in the object. So how can you do that? So you can go like object 1 dot name equals to PQR. So name can be changed. So what happens here is this name will be changed to PQR. Only in object 1, this will still be XYZ and 10. Okay, I hope that's clear. Now, so if I have to repeat in this example, after object is created, its state was initialized. Okay, so after this object is created, this is how this object was created. As soon as the object is created, its state was initialized, or it was populated with class members. Okay, and these members can or cannot have values, and to assign values to these data members, constructors are used in C++ or in other programming languages. Constructors are not used in Python. Okay, just remember that. The way it works is to initialize these values, or right, constructors are used in C++ or in other programming languages, right, object-oriented programming languages. So I want you to remember these two terms. One is to instantiate, okay, instantiation, and another one is to initialize. initialization. Okay, instantiation is object creation with object 1 here. So when I write this statement, object 1 equals to family, this is actually what it is. It is object instantiation, instantiating an object. Okay, the object was created and it gets the members from the family, name and age. Okay, initialization is assignment of values to these data members. All right, and this assignment of values to data members is actually done by constructors in other programming languages, but in Python it's done by Dunder method. And name of the method here would be init method. Okay, it's called init method. This method is used for initialization. Okay, and just treat it like this. So let's say we had these two members. All right, so this statement, object 1 equals to family, it creates this first object. Then I can have another object here, object 2 equals to family, and this object will also have these two members, name and age. Okay, so this is object number 2. It will also have name and age. Now you can also this is object 2, not 1. Okay, so and you can also provide values here, initialize it, object 2.name equals to something, object 2.age equals to something. That's called initialization. This is called instantiation. When the values are provided to the members or the variables, that's called initialization. And initialization in other programming languages is performed by constructors. In Python, it's performed by Dunder method, init. All right. Okay. Now this init method, you know, all whatever method you are studying or function you are studying, it will have return type. It will take certain arguments, return something, all of that. So for init, it takes a few parameters, optional and requisite parameters, mandatory parameters and optional parameters. Okay, so we'll talk about these parameters now, and I'm going to perform a little tweaking in this class. So we have class family. Now I'm going to, now I told you that Dunder methods are called by default, but that doesn't mean you cannot access them. Yes, you can. You can change the functionality. You can tweak, you can modify them to some extent, right? If you can keep up with the parameters and with the actual syntax of the method. Okay, so here I'm going to show you how you can do that. So def, that means I'm going to work with the method, because this is whenever you want to provide definition to a function, you have to use def, right? So init, and it always takes self. Instead of self, you can also use another variable. It takes a variable, okay, and I'll tell you why it has to take it. So we have self, and because in family I'm going to use 2 extra variables, I'm gonna use them as well. Obviously you can change the name name of the variables. All right. Now, I told you whenever you create an object, it gets it gets instantiated, right? And then you can initialize the values. Okay, and every time an object is created, I'm sorry, did I say every time you initialize an object, constructor is called? No, I don't really remember if I said that, but not initialize. Whenever you create a constructor, whenever you instantiate a constructor, instantiation is like creating instance of a class. So whenever you create an instance of a class or whenever you create an object of a class, constructor will be called always. Okay, not just for initialization, but whenever you create an object, constructor is called. Now, depending on the definition of the constructor, whether you have provided any definition or not, the members will be initialized. Okay, so whenever you create an object, whenever this first step is taken, instantiation, constructor will be called, right, in other programming languages. But in Python, instead of constructor, we have this Dunder method init. So every time you create an object, init method will be called by default. Okay, now in this case, here, when I create the when I create my first object, whenever I'll create my first object, init method will be called, and this time I am actually providing definition for this method. So whatever I will write in here will be performed or will be associated, the definition will be associated with that specific object. Whenever an object will be created, init method will be invoked or called. Okay, so self here refers to that specific object that gets created. So when I create object 1, so when this statement will run, object 1 equals to family, self will refer to object 1. If I create another object, object 2 equals to family, self will relate to object 2. Okay, so that's why you have to have this self, or init takes first variable. This actually is it relates to the specific object that gets created at any moment in time, right? So self is like referring to that object. So what happens here is, when you create object 1 equals to family, this gets created, and this init will be called, and now we want to have name and age associated with that object, that specific object. So we are going to write self.name equals to name and self.age equals to age. Okay, what is the benefit of doing this? I'll show you. Just see, I'm going to write another print statement here so that you will know that this method will be called automatically. So init method is called. I'm gonna save it and run it. Now see, family, right? So I'm gonna create, let's say name of the object is obj1 equals to family. So first object is created now. Okay, what is the benefit of using self, name and age? Object 1 equals to family, meaning self refers to obj1. Okay, now since I'm also defining init method, I don't have to use dot operator and specifically use name of the variables and assign them values, initialize them using dot operator or name of the object. I can just provide values in here. So but yeah, it has to be in an order. So first we have self, so this refers to obj1. Then data members of the class, name, so I can have name here xyz, and age, any age, let's say 10. You see, so this method got called when object 1 was created, names were assigned. You can easily assign, you can perform initialization as well, along with instantiation. And to prove that this method actually gets called, you see init method is called. So when this statement was executed, this function was called. Since this function was called, this statement inside this function got executed, and this is the output. This method is called. And behind the scenes in memory, obj1 has been created, and it will have two members, name and age, xyz, and 10 will be the values for these. Okay, and you can also okay, so now these were the data members. Now I'm going to create a method also, another method to print the values. So let's say I'm going to give this method name print method. Okay, and the variable I'm going to use here, or the argument I'm going to use here, is going to be self. Why? Because I want that it should be associated with that specific object that gets created. So obj1 was created. Okay, this relates to obj1. This is also going to take values of obj1, right? So I can just write print self dot name and self dot age. Since these are all parts, it's part of family, you can access name and age, but since it's actually going to be associated with that specific object that was created in that period of time, I'm using self here. So self dot name, self dot age. Now I can just use this one statement. Just a minute, I'll have to save it first, and obviously I'll have to run it. I hope you can see it. I'm just going to copy paste. Okay, so obj1 dot print method. That's it. Okay. XYZ and 10. This method gets called. Okay, so I hope you can understand. When first object obj1 is created, value for data members of the class. When an object, okay, forget about this obj1. Just remember that whenever you create an object, whatever the values are for the data members of the class, these value will also be in the object, right? So obj1 is created, value for data members of the class, which now also are in object, is also passed if the values are there, right? If I have p, q, r and 10 here, then it will also be passed here, p, q, r and 10. And since we have defined init method explicitly in this example, we defined init method explicitly, the values are passed to init method. Okay, self in init refers to the current object. So as many objects as you want can be created. Okay, now understand this. When you add using plus operator, when you use this operator, plus operator, internally I told you this dunder method add is being called, and if you want this plus operator to do something else, what will you have to do? Because when you call this plus, this dunder method is called add. And what does it mean? What does it mean to be a method? Method meaning it will have certain kind of definition. Because of that definition, that specific function is performed. For example, in this case, you defined init function. Okay, you are asking init function to do certain things. Here you are defining print method function. You are asking this function to do certain things, whether it's printing the statements or assigning the values, whatever. So if it's a method, it will have some definition, and when you add two numbers, add method gets called. It has certain kind of definition, and according to that definition, the parameters surrounding this plus have to be, added, whatever, right? So internally, this dunder method knows what to do. If you want, and it knows that it has to deal with numbers, right? So if you want plus operator to do something else, you can change the definition of this dunder method. Definition meaning what it actually does, right? Definition means this whole part, this thing. You can change it, right? Similarly, when you create an object or instantiate a class by creating its instance meaning object. Creating instance of a class meaning creating an object for that class. So when you create an object for that class, or you instantiate a class, or you create an instance of a class, init method is automatically called by the statement or instruction, right? When you add two numbers or three numbers or how many numbers you want, this dunder method is called. And when you create an object like this, init method is being called. Okay. Another example. Okay, I'll take this file. So let's say, okay, right, XYZ and DEF, init, self, this is init, so let's say ABC is the object of this family, right? When you created the object, init gets called. Self meaning ABC, this is init, right? Because you have explicitly defined it here. When you created the object, init will be called, right? And you have explicitly defined, you have given a definition for init here that it will be called. We know that when an object will be created, but what will it do? So in this case, when it gets called, it prints this statement. This is init. That's it. Okay. And if you don't write any statement, it will be called, but nothing will be printed. So if I just say pass, run it, JKL maybe, that's it. It gets called, but since I haven't given anything here, nothing will be printed on the screen or nothing will be performed. Okay, and you can use dir function again to check all the attributes or dunder methods of a class. even if this is a user defined data type or entity, you can still check it. So we have all these init. These are all other Dunder methods, and we also have init here. Okay, and I think yeah, so as in init, we were overriding the functionality. Okay, this is called overriding. We will definitely discuss it in the later video lectures, but I'm just trying to give you an idea. What we were doing here, we were overriding the functionality. In the first part, we didn't define init. We just created an object and we called it. We performed functions and all of that. And we just let it rest in the background, init, right? Init is just resting in the background. In the second example, we used it to initialize data members, right? And in third example, we used it to just print a statement. This is init on the screen as soon as object was created. All right. So that was that's how Dunder methods work. I just took one example, finite function or init magic method, and because I think it is it is going to be beneficial even when you are trying to work with object-oriented programs, right? So I hope magic methods or Dunder methods are clear, and they're definitely used in polymorphism or overriding and overloading, and we'll discuss that as well. Still, if you have any doubt, please let me know. I'll see you in the next video lecture. Till then, take care.